In this video, we're going to look at why optimization in advanced analytics is critical to any business. This particular example is from an AIMS partner in Europe and looks at production planning. So we're going to be showing two examples. The first is designed to show how even a basic scheduling task can be difficult, and the second shows a more complex and realistic production operation that would take hours to schedule by hand in Excel, but could be done easily and quickly in AIMS. So in this first example, we have a single machine that needs to produce 10 products. And in the table on the left-hand side, we see that there is a production time for each product. And then in the table on the right-hand side, we see that there is a changeover time between products. So for instance, to change from a white product to a red product takes 2 minutes. But if we want to change from a white product to a black product, we're going to have a 4-minute changeover wait time. So the key in this problem is to choose the order in which products are going to be made such that the total changeover time over all 10 products is minimized. Now 10 products doesn't seem like that many, and it really isn't. But even so, there are over 3.6 million unique production schedules when we only need to manufacture 10 products. So you could imagine in a more realistic and complex business scenario where you say have 100 different SKUs, it's even more critical to take advantage of advanced analytics and optimization to develop the most efficient production schedule. On the top of this Gantt chart, we have all of the products in numerical order. And just below that, your scheduler or production planner can drop jobs onto their manual plan, and the Gantt chart automatically computes and factors in the production and changeover times. With the visualization tool like a Gantt chart, we can see large changeover gaps in the schedule. So for example, if we swap the blue product and the turquoise product, the production time drops by 7 minutes, from 177 to 170 minutes. So the best production plan found by the scheduler manually was 161 minutes. But alternatively, we can use the power of mathematical optimization to find the minimal schedule length, which here takes just over a second to solve. And when we do that, we see that the minimal schedule length is 152 minutes, which is about 5% better than the best plan found by the scheduler manually. Now this particular example is pretty simple. We have a single machine with only 10 jobs. But imagine we had a more realistic and complex scenario where we had multiple machines and multiple jobs, and we had to worry about warehouse and system capacity. And with each of our jobs, we had deadlines associated with it. This is a more realistic, but also more complex example, and that's what we're going to look at in this next demo. So in this more complex job shop scheduling problem, we have a company that manufactures 6 different products. And each of these different products spends a varying amount of time on up to 7 different machines to be processed. These processes include etching, gold plating, lamination, drilling, cutting, and various forms of testing. And each of these products spends some amount of time on some or all of these processes before they're complete. So on the far right-hand side, we see the diagram that tells us for each product what steps it needs to go through to be complete. And then in the bottom right, we have a table that tells us to manufacture 1 unit of a product, how many hours need to be spent on each of the processes. So what we're trying to do here is create a production plan for the orders that come in from 12 different customers for a number of these 6 different products. So the first thing we're going to do is add the first order to the Gantt chart. And when we do this, we see that the length of the plan takes 252 hours. The next thing we're going to do is add all of the different orders and their corresponding processes to the Gantt chart. And when we do this, we can visually see where the large changeover times are. And what we also see is if we look in the bottom left-hand part of the screen is the total amount of time the manual plan takes to create if we're just randomly and naively creating and producing the incoming orders. And we see that takes over 2,400 hours. But the one thing we do notice is that the first process, etching, is optimized, which means that there isn't a single hour or minute of downtime between any of the orders that come in and need to be etched. But what we do notice is that there is a lot of downtime and changeover time on the other processes. So if we can efficiently and intelligently plan how we want to manufacture our products, we can eliminate some of this downtime and have a shorter total production time. So now that all of the orders and processes are on the Gantt chart, The planner can use their intuition and intelligence and domain knowledge to play around with the different processes. So they can slide processes around. And when they do this, you'll notice that the total production time decreases. Now the planner can do this for quite some time, but at some point it becomes tough to improve. In fact, it isn't even evident or clear on how or even if this plan can be improved any further. So eventually the planner realizes that there isn't a way to improve this plan manually. So what we're going to do is run the optimization. And on the left-hand side, we see the progress window to see the optimization algorithm status. And we see that it takes 8 seconds total for this particular optimization to run. Even more impressive than the number of seconds it took to run are the results. We see that the optimal plan saves over 250 hours over the manual plan created by the scheduler. This is a savings of over 20%. And what we can also do is toggle between the manual plan and the optimal plan. And when we see the optimal plan on the Gantt chart, we notice that the gaps have vanished for the most part, and the schedule is much tighter. And that's what we see with the results, that the total time required to fulfill all orders is significantly lower when we use the optimization than when we use the manual plan. As businesses become more complex, resources become more scarce, and margins become razor thin, it's even more critical to incorporate advanced analytics and optimization into your production planning. AIMS is one tool that you can use to take your supply chain planning to the next level.